Hi guys, it's Miss Olt again, and we are here today to discuss Unit 6.4, Charles' Law. All right, so Charles' Law, a little bit of an introduction to Jacques Charles, was a French scientist, and he did this study with gases that showed that volume of gas increases with the temperature of a gas. And so he figures out that volume is directly proportional. So Charles here, he does a lot of work or research on gases, studying what's the relationship between volume and temperature. So he looks at what happens if you heat up a gas to its volume, or what if you freeze or make really cold a gas? What happens to its volume? And what he finds out is that there is actually a direct relationship between the two, meaning that when volume goes up, so does temperature, or when temperature goes down, so does volume. This would be like why your hands kind of shrink when they get super cold, right? It's the same idea here. He finds that gases obey in the same way. And he is going to use Kelvin temperature. At this point, we figure out that it's best not to use the negative numbers. So all of these from here on out, temperature is going to be in Kelvin. Okay, so that's the big one here, is we want to make sure that no matter what, we turn our temperature into Kelvin. What has to remain the same here? The number of moles and the pressure. We're not going to be able to change pressure around in this case. We're going to keep pressure the same, and we're just going to focus on looking at the relationship between volume and temperature. And as we said, we figure out as temperature goes up, volume goes up, which is why if you were to blow up a balloon and put it over boiling water, it would start to expand, versus if you were to put it in the freezer, it would shrink. Okay, and so here's Charles' Law. I even have it up on the board up here too. It's that the volume 1 divided by temperature 1 equals volume 2 over temperature 2. So this is the equation we are going to use. So let's look at an example here. There we go. All right, so here's our example in our notes, and hopefully at this point you have your notes out in front of you and you're working along here. Our example problem says a 2.0 liter sample of air is collected at 298 Kelvin, and then it's cooled to 278 Kelvin. So we want to figure out what is our new volume. So we're going to plug in our variables here. So we know that our V1 is 2 liters. Remember, this is a unit of units, guys. Liter means volume. Kelvin is temperature, so our T1 is 298 Kelvin. And then it's cooled to 278 Kelvin, so that is our T2. So we're going to want to find V2. All right, so up here, let's rewrite our variables. We know that V1 is 2 liters. T1 is 298 Kelvin, and I don't have to change this because it's in Kelvin. I can leave that alone. V2 is our unknown, it's our X, and T2 is 278 Kelvin. All right, let's make a prediction though. Let's look. What happened to temperature here? Temperature goes from 298 to 278. So that means it's cool. Temperature is going down. So what that means for volume, well, according to Charles' Law, volume is directly proportional to temperature. So if temperature goes down, volume also goes down. So our answer should be less than 2. All right, so let's plug in. So we're going to take 2.0 over 298 equals X over 278. All right, so the best way to solve this is we're going to cross multiply. All right, so we're going to cross multiply here. So we're going to get I'm going to take 298 times X. I'm going to get 298X equals 278 times 2. So I use my calculator and I find that 278 times 2 is 556. So in this case, we're going to just cross multiply these, which is something that hopefully you're familiar with in algebra. So now to find x, I'm going to divide by 298. And I get that x equals 1.87 liters. So yes, my prediction was correct. Temperature went down, volume went down. All right, guys, so your assignments for today is to finish practice 6.4. Here in a minute, I'm going to go through a couple with you, probably go over 1, 2, and 3. And then you have an ed puzzle on Charles' Law. So make sure that you can click on the link on Canvas. It'll take you over to the ed puzzle site. Sign in, and then find the one that says Charles' Law. This should be relatively easy so far because you've done Boyle's Law, you've done temperature, and now you're doing Charles' Law, so it's our third one. You should be pros at this point. But as always, if you have any questions, please don't hesitate to reach out and talk to me. The ed puzzle is due April 29th at 11 p.m. for Maroon Day and April 30th at 11 p.m. for Gold Day. All right, so let's look at practice 6.4. So if you turn over to practice 6.4, let's look at 1, 2, and 3. So number 1 simply is restating Charles' Law. As the temperature of a gas is decreased, what happens to volume? Well, we already discussed that unlike Boyle's, which was an inverse, where when one went up, the other one goes down, Charles' Law is a direct proportional relationship, meaning that when one goes down, the other one goes down. So if temperature goes down, volume will also go down. It will be decreased. All right, so let's look at 2 and 3. So let's do number 2 first. Number 2 says, a quantity of gas at negative 50 degrees Celsius has a volume of 100 liters. What volume will it occupy at a temperature of 77 degrees Celsius? Okay, so I have my first volume is 100 liters. My first temperature is negative 50 degrees Celsius. What volume, my V2 is X, if it will occupy a temperature of 77 degrees Celsius. Okay, before I can even start this though, guys, I've got a bit of a problem. I'm not allowed to use Celsius. I can only use Kelvin. So the first thing I've got to do is I've got to turn my Celsius to Kelvin, which this is what we did in 6.3. So in this case, to go from Celsius to Kelvin, I'm going to add 273. So here, this is 273, and this one is 273. I've got to be in Kelvin. So this one's going to become 223 Kelvin, and this one's going to become 350 Kelvin. All right, now I can plug in. All right, so I'm going to use my equation, V1 over T1 equals V2 over T2. So I'm going to take 100 divided by 223 equals X over 350. And like I said, I'm going to cross multiply here. So I'm going to take 223 times X, and then I'm going to take 350 times 100, which is 35,000. Okay, so I'm going to cross multiply to solve for X. Now to get X by itself, I need to divide by 223. Now before we actually do this, let's make a prediction. What happened to temperature? Did it go up or did it go down? It went from 223 to 350. That means it went up. So what does that mean for my volume? According to Charles' Law, if temperature goes up, so does volume. So I better get an answer higher than 100. So I'm going to take 35,000. I'm going to divide it by 223. And I get x equals 156.9, and my unit is liters. So yes, volume did go up. All right, let's look at number 3. All right, so we'll practice number 3 here. At 75 degrees Celsius, a gas has a volume of 3.22 liters. What volume will it occupy at 75 Kelvin? All right, so volume 1 is 3.22 liters. Temperature is 75 degrees Celsius. Volume 2, I don't know. That's what I'm trying to solve. And temperature 2 is at 75 K. Okay, so first thing I got to ask myself, are all of my temperatures in Kelvin? Well, no. I got to turn this one. This one's fine. It's in Kelvin. I'm going to leave it alone. This one is not. So I need to turn it to Kelvin by adding 273. And that's going to make it become 348 Kelvin. Now that everything's in Kelvin and liter, and I'm trying to figure this one out, it'll be in liters. Let's make our prediction. We're going from 348 Kelvin to 75 Kelvin, right? So temperature is going down. So if temperature goes down, what is volume going to do? Well, remember, this is a direct proportional thing. And so that means if one goes down, the other one goes down. So in this case, if temperature goes down, volume is going to go down. So we should get a number less than 3.22. So let's plug in. 3.22 divided by 348 equals x over 75. Okay? In this case, remember, we're going to cross multiply. So I'm going to take 348 times x equals 322 times 75. So we have 241.5. Now I need to get x by itself. I'm going to take 348 and divide these both by 348. So 241.5 divided by 348. X equals 0.69 liters or 0.7 liters. So yes, our volume went down when temperature went down. All right, guys, so you need to finish practice 4 and 5, 2 problems, give those a shot, and then make sure you go do that ed puzzle. All right, I'll talk to you guys again soon.